Good evening, everyone. I'm Kamala Gunwadhan again, highway consultant and a fellow representative of the IESL Council this time. Let me introduce our resource person for today's event. He's a well-known personality who needs no introduction. He's Professor Tishan Jaisinghe, Senior Professor of Civil Engineering at the University of Moratuwa. Here is a very brief introduction about the major expertise areas of our resource person, Professor Tishan Jaisinghe. He has employed his skills and experiences in structural engineering, computer analysis of structures, and many major designs with researchers, including green technology for further research, developments, and dissemination of knowledge, etc. He has excelled designs and constructions on high-rise buildings together with major structures. Professor Jaisinghe has extended his contributions to the sustainable building environments in Sri Lanka and overseas, and his practical designs and constructions of green factories buildings with the use of many principles as applicable to build environments. With that introduction, he is today addressing you with a topic which is very much harmonized with the today's needs. He will touch how Sri Lanka is comprised with rich tradition of plant-based medicine that can be used hand in hand with modern Western medicine. With that, his main focus today is carbon zero sustainable buildings that utilize construction materials which can be acquired locally. That will be appreciated. He will also express that such modern buildings can offer 5-star comforts and will be very attractive since the whole world is currently facing a huge shortage of construction materials due to a very severely affected international supply chains, mainly due to present pandemic situation. This presentation is expected to cover most of the relevant aspects with suitable examples. My final remark here is, we are much fortunate to share more fruitful programs from Professor Jaisinghe's expertise areas during this session as the chairman of Civil Engineering Sectional Committee of IESL. Please enjoy this important webinar, and without further ado, I invite Professor Tishan Jaisinghe to take over. Over to you, Professor.
Yeah, thank you very much, Engineer Kamala.
Welcome, sir.
So basically, I will use the sheet to introduce certain things, and also I will also use PowerPoint presentation. So now we are going to talk about carbon zero buildings and carbon zero. And carbon is associated with energy usage, especially with non-renewable sources like coal, the petroleum products, petrol, diesel, refined products. They are all, whenever we use them, we have carbon emission. And if you look at the present scenario, say somewhere like 1,800, we are 270 ppm. Today we have gradually reached a value like 400 ppm. Then you'll ask why these numbers are important. To tell you why these numbers are important, we'll have a quick look at the scenario that happened in the world from a time which is 120,000 years ago. From 120,000 years to 12,000 years, this world had an ice age. The world had an ice age. world had an ice age. And so this ice age created a situation in the world where all these areas were covered by 3 kilometers or more of ice. The world temperature was 6 degrees, average temperature 6 degrees centigrade long, less than today. And only the locations close to equator were, and the Middle East were habitable, but Middle East is much more pleasant than today. So if people lived in this world, they lived in Africa, they lived in Asia, they lived in Middle East. So if you look at the map of the world, we have India here, we have Sri Lanka, and we have Saudi Arabia, and we have Africa. So the world map goes like that. And what you see is all these countries had good civilization, but almost nothing in countries like Australia, except close to the top part of the Australia, which is close to the equator. And all the cities like, Sydney, Melbourne, all would have been covered with a thick ice cap, because ice age means countries like Sweden, they're all covered with thick ice cap. All of North America was covered with a thick ice cap. So then you'll ask, I had to also explain something special, and that is, a long time ago, even before we started any of these things, we did not have an India. India was with Africa, so as Australia. So Australia went downside, India went this side, and then India went up, and Sri Lanka was part of India. And it hit and hit and hit and hit, created Everest mountain, so rising up to close to 30,000 feet above mean sea level. We created a huge mountain range. And I said Sri Lanka was with India. It is true, because during the ice age of 120,000 years to 12,000 years, the mean sea level was 125 meters below what it is today. 125 meters below what it is today. So Sri Lanka was part of India, and India was also slightly bigger than this. And Australia and Tasmania, all one land. And Indonesia, there are so many islands. They were all one flat land, one not flat, but one landmass. And New Zealand was much bigger. So when during this journey, which took millions of years, both India, Sri Lanka, Australia underwent through a burning patch on the earth, and all these metamorphic rock that you get in these countries were converted to solid rock. So you get a metamorphic formation, but what you get is very close to this one. You have bedrock, then you have weathered rock, and so weathered rock we say residual soil, or we call it kabuk soil. And not so long ago, maybe something like 60, 70 years ago. People did not use many bricks, but they used laterite blocks to construct houses, and those were called kabuk blocks or kabuk walls. But these days, it's not that easy to get kabuk, good kabuk, because we have used a lot of kabuk that was available, and it's now harder to get strong kabuk which is strong enough to be used as a walling material. And this was available in India. It is available in Australia as well. So because we are having the same kind of formation. Then if you look at a country like England, what do you get? A country covered with 3 kilometers of ice. So you get clay soil, but we call them over-consolidated. Why we call it over-consolidated is they have been subjected to huge pressures. So the behavior of this soil is not the normal soil, normal formations. They are over-consolidated clay soils, and over-consolidation can happen only in clay soils. So we get over-consolidated clay soils. And then, one of the main features of this clay soil is they contain a lot of clay particles, very small particles. And the main difference between laterite soil or kabuk soil is they consist of a lot of clay, small content of clay, silt, and then they contain sand and gravel. Clay and silt content can vary between 30 to 50%, and this content can vary between 50 to 80, 70%. But there are certain laterite soils where the clay and silt content can be as low as 20% also. And there can be laterite soils where sand and gravel content can be as high as 80%. And those are more towards the hard kabuk. Then you'll ask why am I explaining these things? Because these clay soils which are available in Canada, UK, USA, they are very much suitable for agriculture. You can read books written by the Britishers who came here in the early days, like 1830s to 1850s, 60s. When they came to clear the lands in Sri Lanka, lands in the upcountry of Sri Lanka, and convert it to tea and coffee plantations. So basically, it was for coffee plantations. So they went for coffee plantations. But for coffee plantations, first you have to clear the land. And when they cleared the land, they found a very special soil, which needs a lot of assistance for agriculture. Whereas the kind of soil they have seen in UK, that did not need much assistance because that soil is very fertile, and whatever you want to grow, it grows there. So they thought, okay, how can we make these lands fertile? So they actually found the easiest way to make these lands fertile is adding organic substances. And when you are adding organic substances, we can add green color substances, those are leaves, or brown color substances. And the difference between green color and brown color is brown color ones does not contain nitrogen, whereas green color ones contain a lot of nitrogen. So if you're adding leaves to the soil, it's ideal that we add green color substances to the soil. And once you add green color substances, you'll get a soil full of microorganisms, organisms, and microorganisms will create many desirable substances like nitrogen, phosphorus, potassium, and also you can add things like dolomite, and that can give magnesium and calcium. So this way, this is the only way we can actually do proper agriculture in our land, because when you have land, we can do two things. We can do construction and construct cities, and we can also use it for agriculture, or else we can combine both these, and then we can say, let's do green. Let's go green, and go green can be with houses, hotels, office buildings. There are so many things that we can go green. So if you take a construction material like brick, a brick produced in Sri Lanka and brick produced in England can be very different. In England, they use wire cut bricks and they burn it using gas from Russia or some natural gas. In Sri Lanka, we make smaller bricks and they are porous, less strength. And so these Sri Lankan bricks, we call it, we produce it as a cottage industry, and we call it hand molded bricks. Hand molded bricks are, of less strength, smaller in size, more porous, lighter weight, and weaker. And the maximum strength you can get for a brick wall is 1.5 megapascal. Whereas these can allow you to go for 5 megapascal, 10 megapascal, sometimes even up to about 20 megapascal. Because you can burn super high strength bricks. And with super high strength bricks, you can easily go for something like 20 megapascal. So you can construct a masonry building having 115 millimeter thick brick walls, or very easily by using 225 millimeter thick brick walls, because these brick walls are super strong and they are like concrete walls. So if you can get the design parameters right, you can have a 5-story building with only 225 millimeter thick walls. Whereas if we try to do that with our local bricks, we'll have to go for much thicker walls, like 2 feet thick walls, if you are going for 5-story construction. Because of that reason, we did not use masonry, the bricks, as a load bearing material, but we primarily use it as an infill material. Whereas, in countries like England, where they produce very high quality bricks, they use it for load bearing construction. And then you'll ask, why load bearing construction? Because in the load bearing construction, the partition material carry the load. So anyway, we need the partition material. And if the partition material is carrying the load, it's a highly desirable situation, because you don't need a special structural frame for the building. So when you consider, most of the buildings that are coming up in Sri Lanka, mostly, most of them consist of houses by individuals, and very seldom a house will exceed more than 3 floors. So if you can have a strong material that can actually take the load of 3 floors, then we don't need concrete, we don't need steel, and we can do faster construction and also cheaper construction. Then we come to the energy aspect. So to produce a brick in UK, a super strong brick, you need a lot of energy. And to do the same thing in Sri Lanka, again, for that also we need a lot of energy. We have to burn it. But we burn biomass. Biomass is carbon zero, because biomass has already absorbed carbon while it was growing, and now we are actually getting rid of that carbon. So it's carbon zero. Whereas here they use gas, which is not carbon zero. So if you look at the embodied energy, this is high, this is very low. Embodied energy is high and low. And if you want more details on this, you can refer ICE database of University of Bath. If you type ICE database of University of Bath, you can get a lot of information about this. So you can see, now we have a situation where now we are talking about two kinds of energy. One is embodied energy. That is energy that has already gone into for the manufacturing, transportation, construction, and then we are bringing cement, sand, all kinds of things. So finally, when you construct a building, you can work out how much embodied energy per square meter in kilojoules per square meter. Per square meter of a building, we can work out how much energy is needed. And this is very useful, because the moment you are calculating per square meter basis, we can do comparison. So we can have two different building materials. We can do a comparison. So we can compare bricks versus blocks. So that way, we can work out which one is better. And there is another advantage, because we are going, in future we'll have so many other materials for construction, and because of this we can now work out, compare the alternatives that somebody is proposing versus the convention. Right. So on one side we got embodied energy, and the other one side you get operational energy. You get operational energy. On one side you get embodied energy, other side you get operational energy. So when you right, so when we talk about operational energy and embodied energy, now the operational energy occurs every day, and it depends on the design. And then that's why you get passive designs and active means. In passive design, we design the building in such a way it's free running. Free running buildings, generally we can use the maximum, maybe like a fan or evaporative cooler, small evaporative coolers. It's active means we go one step further. Now we'll have air conditioning. Sometimes it can be centralized or even centralized evaporative cooling. Evaporative cooling, evaporative coolers also can be centralized system, then it's more complicated. Whereas here I'm talking about very small units. So we can have a building that is operated either as a passive building or free running building or with passive features like courtyards. I mean, you design a building to suit the environment. Whereas in the other design, like, we know that, it's very difficult to provide adequate thermal comfort inside the building by using passive means. So because of that reason, we decide we are going for active means. And today this has already, there are a lot of sensors, building management systems, BMS, building management systems, and then sensors, and then AI based BMS, building management systems based on artificial intelligence, where you gather the data and make decisions on its own, and optimization, modeling of buildings, and then it has gone to the level of automation. And with automation comes the intelligent buildings. Buildings where you have a lot of things, sophisticated mechanisms like tracking systems. So the building knows where you are going, and then building will respond to your needs automatically based on fully automated artificial intelligence based systems. So it can go to a very high level of sophistication. And you might have facades in the building that can clean on its own when it rains. So because the facades have been designed in such a way that automatically, when it rains, the whole facade will be washed down automatically with no dirt being trapped in any place. So if you take a building like Burj Khalifa, they have those mechanisms where these facade designers have looked at all these different aspects, because Burj Khalifa is in a very dusty environment, and they have so many sandstones and very poor environment surrounding the building, and then they have severe storms, lot of trouble. So they have taken they have pushed the technology to very limit when they were designing those pictures. So now we have two aspects. One is we have soils that can be used for agriculture or buildings. And when you use it for agriculture, you have to make sure you first make it good by adding green materials in layers. So one layer of green material, another layer of soil, another layer of green material, and these green materials can be things like invasive plants. Invasive plants. Why invasive plants is because invasive plants can absorb a lot of nutrients from the soil and store in the leaves. So the moment you use leaves from those plants like manna, or nitrogen fixing plants like Girisedia, Suryakanta, Ipilipil, you can actually easily get a soil which does not look good to be a very fertile soil. And then what you do is, for 10 liters of water, so generally we use rainwater, not tap water, but even tap water can be used because tap water contains chlorine, and chlorine is poison for plants. So generally we try to avoid the use of tap water. And then we add 2 kilograms of all these materials, including grass, finely crushed, and then we keep this container with the lid on this, all this, and then allow it for fermentation for 1 week. And then we take a bigger one and add 2 portions of water. So this water here and additional water here. So dilute it by 100%. So you get double the quantity of fertilizer and add half a liter, half to 1 liter per plant. And you'll find that, because these contain a lot of nitrogen, phosphorus, potassium, and if you add calcium and magnesium to the soil as dolomite, before you do the planting, while you are improving the soil, and then you add all these fertilizer once a week, you can get a huge crop, very strong plants, huge crop. And I can show you, these techniques are used by many people these days. And these techniques have gone on our YouTube channels. So a lot of people are very happy about these things because you don't need any insecticides or pesticides to control any problems in your plantation. And with this, people are now getting away from hybrid seeds. No more hybrid seeds. People are going for our traditional plants because people went for hybrid with fertilizer, with chemical fertilizer to get a big crop. But you can do the same thing with traditional. But if you want a good crop, you can spray enzymes. Enzymes are there, and those liquid enzymes can be sprayed onto the plant. And the moment you spray them, the enzyme can be bought readily in Sri Lanka, made in Sri Lanka by Mr. Shara Herat. He makes it. These are his inventions. The moment you add enzymes, what happens is the plants can absorb all the nutrients in the soil in a very systematic manner, and you get a huge crop. So you can go for traditional farming and get a huge crop. And these are very important for today's topic because we want a totally harmonized system for promoting tourism. So on one side, we have a good soil, laterite, which is superb for construction. And how you make it superb is by stabilizing it. And for stabilization, we use cement. So I will show you in a moment. I'll show you a lot of photos and the systems, different systems that can be used for our buildings. And our buildings, the idea is minimum embodied energy and minimum operational energy, so that all this operational energy can be compensated by using electrical energy from solar. So we can compensate for all these energy needs by using electrical energy from solar. And again, for electrical energy, also we go for a very special system. And what we do is we do not feed the grid. Why? When there's a power cut, your building, no electricity. But the problem is all these are not feed in the grid. So electricity systems, so rooftop solar is a flop. Why? When you don't have electricity, it's not giving you electricity. And when you don't have electricity, you are not feeding the national grid either. It's a flop. So how do you make it a proper system. You go off grid. So what is the difference between grid and off grid? So grid, you have inverter which allow electricity in only in one direction. Off grid, you have a special inverter, it can allow electricity in both directions. So what you do is you go off grid and then you go for rooftop solar. Then you get a inverter. If the inverter is 3.5 kilowatts, you need to stabilize it. This because solar is not constant all the time. To stabilize it, you need two numbers of 100 amp hour deep cycle batteries, and that comes as gel batteries. And gel batteries are used in hybrid cars. Gel batteries are used in hybrid cars. So what you do is you get two numbers of 100 ampere hour hybrid car batteries with 3.5 kilowatt, two batteries with 5 kilowatt inverter, off-grid inverter. You need four batteries. So the inverter is an intelligent inverter where they use software and AI techniques, so many different things to make them super efficient. And the high quality inverters are available in China, and you can use them. So basically, you will end up with something like this off grid. And what happens is you will have a small switch, and at 6:30, you will change over from grid to off grid. 6:30 a.m. you change off from grid to off grid until around 5:30 p.m. System will work on solar. After 5:30, automatically it will go on batteries. So these 2 and 4 are the minimum. You can have more batteries. So depending on the usage that you need, you will fix batteries so that all these batteries will be fully charged during the daytime. And then they are all ready for serving you by the time darkness comes. And then until around 8:30 p.m. to 9 p.m., depending on the usage, depending on the battery power, you can stay off grid. Then, and we like you staying off grid because electricity board has failed to give its intended service because they have failed to go for another 900 megawatts of coal at Norachole and another 500 megawatts of coal at Sample. And because of that, and with these two plants, now we have only 900 megawatt, and we are talking about another 900 and another 500. So total would have been 2,300 megawatts. And the maximum we need is about, we could have done many other things when you have more power like this. And if you look at Mahabali Scheme, we have a cascading system of dams, so many dams. So we have Upper Kotmale, then we have Kotmale, then we have Victoria, then we have Randanigala, then we have Rantham. And when you consider Randanigala and Rantham, they are like this. So we can actually pump from Rantham to Randanigala. And this is called pumped storage. So by pumping back, we can actually keep high base load. And why we encourage people to join at night is we want to run these coal power plants, we need high base load. And the only way we can get high base load is encouraging people to be on the grid. And if they want to use air conditioners or whatever, if they want to work overnight using computers, they want to have few lights to ensure that there's sufficient security. We encourage all of them to do all those things while being connected to the grid. And also we can encourage factories to be run overnight shifts, because the electricity become really cheap during the night, extremely cheap during the night time, because we have so much base load. So doing all these different things simultaneously, we can go for energy security in our country, because whatever you talk about tourism, energy security should be there. And when the moment you go off grid, energy security is there. And then what we do is we have to ask, coal, is it poison? No. Our carbon footprint is less than 1 ton, and USA it's 17 tons, Australia it's 15 tons, UK it's 8 tons, Germany is 9 tons, France is 5 tons, China is 5 tons, India is 2 tons, Sri Lanka is less than 1 ton. We say we don't need coal, whereas all the other people, China say they want coal, India says they want coal, Australia says they want coal, America says they want coal. But Sri Lanka, which has no hydro, not enough hydro, Sri Lanka, again, not enough oil, we have nothing to burn, we say no to coal. Now you can see how ill-informed our politicians are. They are really ill-informed, because you are the politician, and then you have a ring of people, and they never allow any proper information going to the top man. And you have various people, and they have qualifications, PhD, they have medical degrees, so many other things, but the information they give is wrong, and then they persuade the leaders to take wrong decisions, and then plunge the country into deep trouble. And today what you see is that kind of crisis, because in a country where our carbon footprint is less than 1 ton per person per year, we are saying no to coal when the whole world is saying yes to coal. So you can see the ill, but nevertheless we say yes to diesel, and we also say yes to heavy oil, and we also say yes to diesel generators, and we also say yes to combined cycle. So this might be better, in today's prices, this can cost about 50 rupees. This might cost about 120 rupees. This might cost about 70 rupees a unit, 7 to 8 rupees a unit, combined cycle, because it's more efficient. And this is 120 rupees. Whereas if you go to many countries, I mean, Russia was very big, and around Russia there were so many countries, Belarus, Ukraine. Do you know what's the price they sell electricity? They are only 3 to 4 US cents per unit. 1 kilowatt hour is 3 to 4 US cents, or even at 300 rupees per 1 US dollar, this means 9 rupees per unit. 9 rupees per unit. They provide industries 9 rupees per unit, whereas we might be providing 90 to 100, 90 to 40 to 50, but even that, each unit CEB makes a loss of 30 to 40 rupees. Now you can see the illogical planning that we have undertaken in our country. And so at least now, with this deep crisis, time has come for us to take, take proper decisions. And we should be ashamed that we had engineers in CEB when so much wrong decisions have been taken over a long period of time. Now let's see how all these can be summarized. So on one side, we have the soil, and which is good for construction, and also can be improved a lot to be superb for agriculture. And this soil is none of our make. We have no responsibility on it, because it is due to the fact that Sri Lanka, India, and Australia underwent through a patch of burning patch. It created a lot of rock, and then rock later weathered and finally formed a weathered soil which is full of silt. So we need special effort for agriculture, and that can be easily done, because now today we have modern systems for organic farming. And if you want more information, type on YouTube MTR Jayasinghe SL Organic, and you can learn a lot about organic farming in that particular website. There are videos, there are presentations as I do now, and you can get a lot of information. So that is on one side we have soil. Then we have energy. And for a building, we have two scenarios. One is embodied energy, and on the other side, we have operational energy. And both will depend on the building material. Material we use, whether we use bricks, blocks, or Dura boards, or autoclave ACC, aerated autoclave AAC blocks, or aerated autoclave blocks, or EPS based lightweight concrete, or aerated lightweight concrete. Aerated lightweight concrete, there are so many building materials around us, and in addition to that, we also can have cement fiber sheets, and they can have two types. One is asbestos, which has asbestos, and other one is free of asbestos. So if you are doing any kind of green project which is not allowed, then you have to go for asbestos free fiber sheets. The problem is asbestos based fiber sheets are very strong. Asbestos free fiber sheets are not that strong. That is the difference. So if you are doing a normal project, you want to hit the minimum, you can use asbestos, because the type of asbestos filament that is available that we import to Sri Lanka is curved, whereas the one that causes cancer is called blue asbestos, and it has a straight filament, whereas the filament of the gray asbestos that we have imported to Sri Lanka over the last 60-70 years It is all grey asbestos, and grey asbestos never cause lung cancer, whereas blue asbestos can cause lung cancer. But fortunately, we have never got blue asbestos in Sri Lanka. Because of that, asbestos can be used, as well sheets can be used for construction. But if you are planning to get the Sri Lanka Building Council or LEED certification, never use these asbestos containing types. That is not allowed, because they specifically say you can't use any product with that contain asbestos. Right. So basically, we can have so many different materials, and the energy that we need to operate the building will depend on the type of materials that we use. For example, you can have 5mm glass, then 5mm special glass, and not only that, we can use 5mm double glazing. That means two glass layers side by side, separated by a gap of about 20 to 30mm. You can get so many different types of glass. So the amount of energy that you need to make a building comfortable will depend on the amount of glass, these materials available. So basically, on one side we have the energy scenario, and if you want to make something carbon zero, what you have to do is reduce the embodied energy, and reduce the operational energy, but you can't make it zero, so go off grid. So you need energy to run the building, but you run it off grid by generating solar-based electricity. And if you want to make it really zero, then what we do is we do two things: on grid and off grid both. So off grid will minimize our dependence on the grid, and on grid will feed the grid. So because we are producing more energy than we need, our building will automatically become carbon neutral or carbon negative. So that way we can make sure whatever the facility that we operate has two systems. One is off grid and the other one is on grid. So both will assure the rooftop solar can make your building carbon negative, not carbon zero. You can go into the negative territory. That means your building is not using any electricity, and actually it is generating electricity for the national grid. So with this background, I will now show you a little bit about the different materials. I'll quickly run through a presentation. So what I do is I'll stop this and share the screen. This one presentation. So basically, I will show you this some materials. So earth is a fantastic building material, and if you can get hold of this book, just go through it. It's about unstabilized soil, and then when you use stabilized soil, you know there are so many restrictions. It can be manufactured. Then we have tested them, rammed earth, and then we have used them in real buildings as blocks. And then if you want, you can plaster these. And this house used to that is one of the houses that I have built in 2006. It's a huge house, 3-story house, and this used to be this was the house that we lived before we moved to Piliyandala with a small house. And then you can do rammed earth with steel shutters, and you tamp it, make rammed earth like this. Then other option is to go for timber shutters like this, reinforced, tied, and you can make nice walls like this once you form these formations, either with cement stabilized rammed earth or any other material. And these are houses in it's a house in Kotmale, And this is a house in, this is a building in Germany. And you can, and here you can see even the foundations are made out of cement stabilized earth, retaining walls are out of rammed earth, foundations are out of rammed earth, the walls are out of blocks, and so on. And then you can even use these debris, crushed materials. The moment you recycle the material, the carbon footprint of those materials become almost zero. Embodied energy becomes very little. And we had all these facilities in gold, but I think some of them may not be working because these facilities were set up after the tsunami of 2004. And whether they still, these councils still operate those or not, I'm not very sure. But these are very much used in countries like America and Germany. They do a lot of recycling by crushing the already used materials, and you can do testing. And what we found was there's no problem in using these crushed materials, already used materials. And then there's another example of how to use materials, used materials like expanded polystyrene. And using the expanded polystyrene, one engineer called engineer Niranjan Fernando is actually having this big factory, and he's producing these panels using cement stored in silos and big molds, vacuum plants, and uh, and the beauty is, we have done a lot of testing on those materials, and then we have gone for model house construction. It's a large model house with 4 bedrooms, and we have done all the modeling, and then we have constructed the house. Not only constructed very nicely, but we have done load testing. So a lot of research has gone into all these materials. And then we have expanded it for apartment buildings. And here you can see all these apartment buildings. And then this is aerated concrete blocks, or you might also call aerated autoclaved blocks. And there are a lot of properties that can be used. And I will share this particular presentation with engineer Kamala Gunawardana, and you can actually have a look at this. You can keep a copy of this presentation, which contain a lot of information. And then we have natural materials like Dura, and you can see Dura is strong. Even elephant can stand on Dura. And Dura comes with acoustic panel, laminated panel, normal panel. And if you want how we can use it, I used it in a large building complex where I have put up 58,000 square feet of two-story buildings and 1 3-story building, all completed in 2 months. And these are huge buildings, and the walls are all Dura but mounted with cement fiber sheets. And then you get Dura again mounted with, not mounted, but sealed with polythene on the upper side, and the lower side is exposed. And even if you go today, it's 7 years after the construction, still without any maintenance, these buildings are in good shape. But now every building must be properly maintained at least once in 2 years to look after it. You have to look after the building. Otherwise, things can go wrong. Minor things can go wrong. You ignore it, then it becomes a major defect. So basically, I have asked this hospital director to, initiate a program of maintenance, because you cannot run buildings without maintenance. And these buildings are so important because these are for operation theaters. Now they have the cardiology unit in it. So there are so many important things in these buildings. So they have to actually properly maintain the buildings as well. And then you can have these lightweight systems where you cast the panels. So these days, these are very important because the cost of 1 ton of steel with all the fabrication cost has gone up to close to 600,000 rupees per ton. Used to be about 250,000. Now it has gone up to about 600,000 rupees. But still, the biggest problem is there's no steel in the market. Even if I'm willing to pay 600,000 rupees, there's no steel in the market. That's the biggest problem. And then you can test the precast panels, and then you can load test it, and then you can get this kind of finishes. If you don't like the beams to be seen, you can have a ceiling underneath. And then you can have these ICC hollow cross subsystems, or this system which is lighter but very easy to install. Or on the other hand, you can go with nerd center systems, and you can see get a finish like this. And for that particular two-story building, we use nerd center system. And then you get aerated concrete blocks, and then these tiles and so on. So basically, what I've shown you is there are so many materials. Then what is the concept for these hotels? And the concept for hotels is, I'll stop sharing and I'll share the presentation with you. You can just go through it. It's self-explanatory. So the concept is, you have to look at Sri Lanka, the country, and we have very nice beaches, and we have ruins here. And we have national parks here, Vasgamu, all these national parks are here. And here you get hot water. You get hot water wells in Trinco, and then places like Lankapatuna and Koneshwaran and many other places of interest. And then when you come here, Arugambe. So if you want, if we set up some hotels in these areas, that is northern eastern province, and close to a reservoir. So this is the concept only. So you can develop it. So you have a reservoir, and then you take some adjacent land. Then you can have large farming wells that will allow you to have large water tanks to get enough water, and then you can go for a hotel like this, hotel concept based hotel with swimming pool in the middle. The idea is, this is the kind of idea that is used in Hotel Chandrika of Maharama. And then these areas you get staircases, reception and all those. And these areas you get the hotels. And then you will have some other areas reserved for organic farming. And then you can have some other area like canal, where the water levels are maintained at 1.2 meters. Here also water levels will 1.2 meters. These are all natural swimming pools. So whatever the water comes, it will be removed and used for farming. So we create a new concept, and then the canals can give us a lot of soil, and all those soil can go into the construction of. So our aim is, say, no steel, no concrete. When I say no steel, no concrete, I'm just meaning minimum amount of steel, minimum amount of concrete. Because sometimes it's desirable to have a little bit of concrete. Basically, I mean, so not reinforced concrete, but very lightly reinforced, little bit of concrete. So the whole idea is, people live here and they come on half board, and we look after their breakfast, dinner, but in between they are on their own. In between they are on their own. So from the hotel they can go to any of these places during the daytime, and vehicles will be arranged for them to go on to any of these places and enjoy. Then when do they get the health part of it? Health part is from dinner to breakfast. You get dinner. So because health-based tourism can become very boring unless you link up it with some good activities. So then you'll ask, What is the basis? Basis is you charge something like $100 per night in very well constructed hotels where all health treatments are free. Then you'll ask, how do you do all these things? What are these health-based uh, problems? So what are the problems that people face today? They are overweight. What is else? They have gastric. They have pressure. They are all non-communicable diseases, pressure, high blood pressure, sugar, diabetics, then heat ailments. Heat ailments. What else? They have so many other problems. They may have kidney troubles and yeah, skin rashes and mostly cancer. So many illnesses. And if we can cure most of it, then we have a good market to capture while ensuring that we entertain them as well. Not only treatment, but they are free to move out and entertain themselves, but all this will come in the night. So this has to be based on plant-based. And what you do is, I'll quickly show you what are things we have at our hand. We have yoga, we have exercises like cycling, swimming, walking. Then we have relaxation techniques. And these are particularly suitable for cancer patients and developed by Dr. Ian Bowler. You can actually type Ian Bowler cancer, then you will get all the information about these. And then we can also have meditation. And when you say meditation, it's only one meditation, it's samatha meditation. So it can be breathing or metta meditation or those things. Because if you go for the next stage, that is vipassana meditation, you are going to the Buddhism because you can't go for one religion if you are doing meditation. So you have to stop with samatha meditation. So you have to stop with samatha meditation. We will not go for this level unless somebody asks for it. So you can see so many things: yoga, exercises, relaxation techniques, meditation, so many things that can be coupled with the health-based tourism. So the whole idea is, I'll show you how this health-based medicine, plant-based medicine is the principle of plant-based medicine is simple because it says every plant-based medicine you have decoctions and every decoction is only 60 grams or 5 into 12 grams. And in singular, it's all 5 grams is called 1 column. 1 column is 5 grams and every decoction is 60 grams. So then you see, if you have phlegm, you list out the main treatment, the plants that are suitable like Venivalgata, Valmi, Tippili, Pavatta, fresh ginger, dried ginger, Yakinara. So many plants that can be used to treat one. Then you have blood cholesterol, You have gatatumba. Then you have sugar. You have Kotala Imbutu, Panorama, so many. Then if you have blood related or skin related problems, you have another set of medicine called Aralu, Bulu, Rathanun, Helapatu, Dumma Dandu, Dandu. When you get so there are so many medicines. So what you do is in this plant-based medicine, we want to, what are things we are going to cure? What are the problems generally we have? Most of us are overweight. We have to make them as normal weight. And we might have cholesterol, and which can be cured by using exercises. Because you can, when you exercise, HDL will go up, LDL will go down, the ratios will improve. So cholesterol can be sorted out with exercises. Then we have other illnesses like kidney-based illnesses, and you might also have cancer, all kinds of illnesses. And cancer is something that needs special treatment because it needs 16-hour fasting every day, and 1 day a week you need 24-hour fasting. The cancer treatment, and then you also need operation. If it is serious cancer, then you have to get rid of all the cancer cells, and then you need chemotherapy. But all these can be, the effectiveness of all these can be enhanced with plant-based medicine. Because what happens is chemotherapy is given once in 14 days. So until the next one comes, you have nothing to do. You become depressed, not knowing whether the chemotherapy is working or not. So the best thing is, if you are a cancer patient, keep you occupied all the time. There are plenty of things to do, and by doing all these things, you are going to be cured. And with that confidence, you can overcome. So if you want to get rid of any kind of illness, you write a decoction or Aralu, Bulu, Rasakinda. So basically, I'm making the base and Handun, and then Ahelapattu and Dummaladandu. And how this works is, this will, Aralu is a very good, medicine for, removing the poison in your body. Bulu can balance it. Rasakinda also can kill the poison. Rathanun is also can kill the poison. Ahelapattu will remove the poison, kill the poison. Dumaladandu also kill the poison. Then you get Pohomba Potu. And when you are will enhance your immunity, and then you get Niramulya. Niramulya will remove all the toxins from your body through kidney, and then you get Senecola. Senecola is a wonder drug where one of the Germans identified that, and he took it to Germany, and then he made a medicine pill, and then he started manufacturing it in Thailand. It's available on Amazon, and they call it Senpot. And Zencott is used widely in America for treating the cancer patients to remove the toxins in their body. And so I know a nursing manager, her husband was our research assistant in one of the international projects. So they told me that they use it. So we have 10 items, 50 grams, and we can have 2 more items and 10 grams. And those two will be based on the illness. So if you are having phlegm related, then you use these last two, 1, 2, last two, use Valmi, Tippili. If you have sugar, last two you use Kotala Imbatu and Ranaramal. If you have gastric, for last two use Kalanduru Ala and Belimul. And if you do not have anything, no visible one, then what you do is you use Velmi and Belimul. And if you have kidney trouble, use Kiribaduala and Nerechi. And if you have cancer, again you use this. And if you have cancer with gastric, you use this. Likewise, you can treat any illness by using a simple system like this. And what we do is we create a base, and then we keep few medicine to address the real illness, because the base is to detoxify the body, because we are using a lot of chemicals in our food. We have used sauces, we use our food is grown in inorganic manner by adding a lot of chemicals. When you buy dal, you think dal comes from India. No, it comes from Australia and Canada. They use a lot of chemical fertilizer. They use lot of pesticides, lot of insecticides, lot of weedicides. So the dal that you eat is full of chemicals, and all these chemicals accumulate in our body. Because of that reason, many people have a lot of illnesses. By the time they turn 50, 60, they have a lot of illnesses. Whereas if you look at our grandparents, they never had any illness because their food never had any chemicals in it. So the whole world is full of sick people today. They are all sick because they are eating a lot of chemicals in addition to eating food. So because of that reason, we have a lot of problems, and all those problems can be easily solved by detoxifying the body and then getting people to engage in good activities like yoga and meditation, exercises, and enjoy the life. And like going to see the various safari, ancient ruins, or sea baths, allow them to do anything they like during the daytime. And then how are we going to construct our hotels? Our hotels can be out of, I'll come to the foundation later, can be out of rammed earth, where you can use 4% cement for stabilization. And what we do is this is one of the options only. You can use concrete, but concrete is very expensive these days. So what you can do is we can go for trusses based on timber trusses. Then what you can do is these floors can be out of Dura panels, And if you go to Ulagalla Resort, Ulagalla Valawa Resort, the floors are all out of this. And then to make it more durable, we mount it with a 4 millimeter thick cement fiber sheets. So on this, you can, if you want, you can have ferro cement layer, and then you can do tiling, or you can just put a carpet and make it very nice. And then you go up and another layer, and then we can have a side stop for the roof. And then we can bring in zinc alum sheets and then cover it up. And then, we can make it accessible because this is almost flat, although I have drawn it with a slight inclination. We can make it very slight inclination. And on top of all this, we can have a thin concrete layer, and then we can even use it for some kind of organic farming or recreational activities. There are so many things that you can do the moment you start thinking outside the box. And then for the foundation, what we do is we use cement stabilizer and compact cement stabilizer with 6% cement, and we make a foundation of about 150 millimeter, and we make it slightly bigger at these places. And then what we do is we embed 3/4 metal into it. On that embedded one, we will go for a concrete foundation, concrete layer, and on that concrete layer, we'll use only 6 millimeter bars just to keep it, integral. And then what we do is, when it comes to this level, we can actually have a terrazzo, a 12 millimeter thick terrazzo on this concrete, and we can finish it. Then once you have the terrazzo, what we do is, next day we cut it into 600 by 600 squares, fill it with a tile grout, and generally we prefer a tile grout with black powder so that it looks black. And then we polish it. Once you polish it, you'll get a nice terrazzo finish. And these places you can have carpeted finishes, and you have upper floor here. So you can go for something like 3 to 4 floors by changing the cement content and the compaction effort in these walls. So you can have 3-story or 4-story type hotels, and you can plan these. Now you can see we get the soil from the site, so there's very little embodied energy in it. Then we get cement. There's some embodied energy in it, but we use it very little quantity, so the overall embodied energy will go down. Then we are using natural materials with very little embodied energy, so we create a hotel with very small quantity of embodied energy. But all these floors, everything can be plastered and then finished to very high level, which can reach a level of a 7-star type comfort, because we are having a lot of recreational activities, swimming pools, and those are all natural pools. And then very nice interior in the rooms, and large washrooms, and you can provide bathtubs, all kinds of facilities. And then you can design high-end facilities with hot water and all that. Again, hot water, all those things can be solar based, and we can have very nice situation. And if you really want to improve further, if you want, you can have ice machine and use generate ice that can be used during the night time with evaporative coolers. Rather than using air conditioners in the night time, you can use, because this is in the dry zone, you can easily get a huge benefit in the thermal comfort by using ice based evaporative cooling, where the cool air that is blown is really cool, and that makes the people very comfortable, and they are much more comfortable than normal air conditioning. So basically what I showed you is, so there are so many new things that we can think, because we are in a real crisis today. Because on one side, we have a huge problem, because by keeping the dollar at 100, 203 rupees, we have trained our people who are migrated to other countries, and also the workers. the benefit of sending the money illegally. Illegal manner, they get huge benefit. So when the government is offering 280, with illegal means you can get 320. Earlier, the difference used to be only 1 rupee, 2 rupee, but now it is 30, 40 rupees. With such change in the legal and illegal system, the legal system is going to suffer hugely. So what we can see is very difficult for us to go for traditional construction, because our traditional constructor depended a lot on imported materials. So we have to go with locally developed materials. So the locally materials are Dura, cement stabilized rammed earth, CSRE, or cement stabilized earth blocks, CSEB, or it could be a material like terrazzo instead of tiles, because tiles are so expensive, because there's again a black market for tiles. So you go with terrazzo, and you go with things like carpets, and you can think of getting locally made carpets. If you create enough demand, there will be many people who are willing to produce high quality carpets in Sri Lanka. So we have to create a situation where we complete hotels with new concepts and also carbon zero, and off-grid autonomy is there. So basically, you are having electricity all the time. The moment you do all these things, you'll find that we might stand a chance of creating a new situation. And then I'll tell something not engineering, and that is the movement of Saturn. So this is actually based on the Hinduism science called astrology, and they have the movement of Saturn, and every 2.5 years, Saturn moves from one position to the other on 29th of April, and 2.5, and then another one 5 years. So basically, people talk about 12 stars, and one position to the other 2.5 years. So they talk about 30-year cycle for the Saturn movement of the Saturn. Because of that reason, they say the history repeats in the world generally in every 30 years. So one option is 1929, Wall Street crashed in America, huge world crisis. 1959, SWRD Bandanak was assassinated. 1960, 61, 60, very bad years with a lot of elections, a lot of trouble. And then 1989, again JP had trouble, huge trouble. 2019, this attack of 21st April. So, and then if you look at 1932 to 1939, 39 came Second World War, 32, 39, good times, 1962 to 1969, good times, 1992 to 1999, good times. So because of that, there's a chance that 2222 to 229 can be very good. So think positively. So the chances are, if you go with new concepts, out of box thinking, and do things positively, you have to believe the stars are on your side. The chances are things might work very well for you. And if you are an architect, engineer, you can form teams, find investors. It's very important that we find investors. And if you want any information on all these methods, contact me. I'll give all the information free of charge. So it's free of charge information. no charge. We'll tell you how to do your consultancy, and then find investors, encourage them to go for this kind of out-of-box thinking, so that in Sri Lanka we can create a new concept in these areas with so many hotels, because Eastern Province has 1034 tanks. And tank is a Portuguese word. So there are 1034 tanks. Tanks means small reservoirs and large reservoirs in Eastern Province. And if we start with 30, 40, 50 hotels like this, new concepts, there will be huge mass with wealth in the Eastern Province. And with that, the chances are we might be able to pick the tourism. And because the beauty of this tourism is US dollars are in Sri Lanka, not outside Sri Lanka. We don't have to beg anybody, because people come with money and they spend the money in Sri Lanka. And we need a special system to reach 5 million visitors per year. That's a kind of 4 to 5 million visitors per year. Cannot be done with the current systems, because the moment you try to go beyond a certain point, our systems will be stretched to the limit. So before that happens, it's up to us to ensure that we are ready with new concepts. But the beauty is we have a superb expressway system. Going to this way is nothing, because up to Kurnagal now there's an expressway, and the Candid Road is also 4 lane. So one way or the other, you know, from my home at Piliyandala, I can go to Kandy in 2 hours, Trinco in 5 hours, and Kataragam in 2.5 hours. And yesterday I came from Nigambo to my home at Piliyandala in 1 hour. Leaving Nigambo at 9 o'clock, I came home at 10 o'clock. So basically, and also Mattala, and from there you can go to Arugam Bay in 4.5 hours or 5 hours. You can be in Arugam Bay. So the whole Sri Lanka is kind of well connected. If you want to go to Jaffna, now it takes only 6 hours from my home. So you can see, I can travel to Jaffna as fast as I can travel on the train. Generally, trains are very fast. Generally, trains take less time. But now the private vehicles can come closer to the trains, because the road network is so good. So everywhere you go in Sri Lanka, it's carpeted roads, and with this kind of move, the government patronage will be there for this kind of projects. And then if we go for this kind of out-of-box thinking and go for new projects, there is a chance that we might be able to pull out of the mess. So with that, I will end the lecture. Thank you. Engineer Kamala?
Yeah, Professor. I think now it's time also 8:40. So we are continuously.
We started a little late.
Yeah, so a very valuable and very interesting presentation from you, Professor. You took us to a very healthy and relaxing environment, and you showed us how this comfortable local construction materials used in zero carbon environment, and modern buildings which can give these 5-star comforts. So we have actually, I think I enjoyed it, and all others maybe they have enjoyed it. This is really what I felt. It's a blending with the requirement with present context of materials focused with the present requirements, contesting with these issues. So I believe that you all grabbed what most of the essence out of this webinar, including, as he explained, with this organic and local materials and relaxing environments and meditation, breathing. So all those things and to enjoy the life also. So actually, so this is a compressed mass of a vast spectrum. So specialized area to 1.5 hours. So I know it's very impossible for to finish such a vast area. So I think if we have time, either we can accommodate another continuation session later. I think Professor will do that. So
Yes, sir.
yeah, a very big thank you to you, Professor. And once again, your untiring efforts, we appreciate a lot. And because you share your wonderful expertise, knowledge in all the area. I mean, direction is all over the circle. So it's it our members who wish to enjoy the even non-members also we could have.
Actually, now I'm sending that particular presentation on building materials to you. The PowerPoint, sorry, PDF file that I showed you all the pictures.
And now?
Yeah, I have emailed that to you. So you can actually make it available in a downloadable form in one of the sites, and then give the link. Then they will be able to download the presentation.
You can share the link.
Yeah, share the link because I have given the link.
Okay.
And I will send another file.
Yeah. Okay. Actually,
can overlap information, but I will send another file also.
I can't hear you properly. Yeah. Okay. Let me thank the team behind this IESL hosting with the hosting team of the Secretariat and IT team of the Secretariat for your support. I thank you, both of you teams. So thank you, our members, participants. So you enjoyed the thing, I hope. Actually, I would like to make a small reminder. Tomorrow we have the project planning and monitoring demonstration of MS project software applications. This is the 4th lecture, and it will be the final lecture as well. So with that note, I think we will conclude the session. Professor, anything else?
Yes, actually, can you share this with Mr. Engineer Imanta as well, so that he can put it onto my YouTube channels as well, in addition to the IESL class. Imanta Dharmasiri, the person who is doing the YouTube channels, our engineer Manjulu knows you.
Okay. I will talk to him. Yeah. Okay then. Good night, everybody. Thank you very much again.